link, right? The Quizlet group. Did you see it?
Yes, sir.
Did you try the quiz?
I read through the flashcards, some of them.
Alright, good. As long as you attempted it. So for the other students, because I can see who joins, I can see your progress. So for the other students, I'm going to implore them to practice it as well. Because even though we're on different topics, I don't want you to forget the other topics that we've done. Alright, so at the end of each week, you should use the flashcard, right, the learn, and then you play a game with each topic. I'm going to go through that for everybody though. So I'm going to post in the group on the instructions for the Quizlet. So for David, Kiman, and Nicholas, can you turn on your cameras for me so we can begin? Alright, so we're talking today about operations, right? Last class we did defined arithmetic operations where we gave meaning to a symbol. Today we're going to look on the definition itself on addition, multiplication, division, and good morning, and subtraction. And we call those the identity. So what does addition mean? We're going to know the identity of addition today. So right for me, identities. So mathematics. And the topic for today is identities. What makes addition addition? And what are the parts of addition? Alright? Here we go. The first thing we're going to look at is addition. Alright, let's begin. Let's minimize. There we go. Alright? So I'm going to ask some questions. The first one, addition. David, give me an example of two numbers being added together. David? Give me an example of two numbers that you add together. Any two numbers that you're going to add together.
5 plus 10.
5 plus what? 10?
Yes, sir.
Alright. My apologies. So 5 plus 10. 5 plus 10. Okay? Now, this has an identity. You do know that there's two terms and there's a symbol in between, plus. When we look at this, right? We could say, for example, David has 5 cards. David has 5 cards, right? And he gets an additional 10 cards. So whenever you see this computation, right? This means, therefore, once again, what's the stuff? Let's say 5 plus 0. 5 plus 0 can be written as 0 plus 5. And it doesn't change its meaning, right? So therefore, addition has an identity that says if 0 is added, if 0 is added to any number, if 0 is added to any number, or vice versa, comma, the sum the sum is the number itself. Alright, underline the word sum for me. We're going to define what sum means. So quickly tell it out for me. So, one person, David, what does the word sum mean? David? Oh, I called on David already. Let's say Jazia. What does the word sum mean?
in all, sir.
Alright?
Everything in all, sir.
Okay, so sum means the result, right? So let's say, for example, I have an equal sign, and 5 plus 0 would give me 5. This 5 would be my sum. So put that little diagram and an arrow, and then you're going to put sum for me. Alright, quick revision. What do we call these two terms? Pair. We're dealing with addition. Each term in an addition is called what?
An addend.
Excellent. An addend. Alright? I'm going to just quickly put it over here. It's called an addend. Alright? So we've identified two things so far. Addends should be two addends. But we're missing one thing. So these are addends. And we know the result is a sum. Alright? But what do we call this symbol in the middle? Isn't it plus? So that's the part, or this is the identity of addition. Alright? The identity is that if 0 is added to any number, or vice versa, the sum is the number itself, and the parts of addition is that you have two addends with a plus that gives you a sum. Any questions? So if, for example, you get a question on the exam that says what is the identity for addition, therefore you can say 0 is the identity for addition of numbers. Therefore, zero is the identity of addition for addition of numbers. Alright. So 0 is the identity of addition. One second, there we go. Alright. The reason why 0 is the identity is because if I add 0 to anything, it remains unchanged. Alright? So write that for me. Our value remains unchanged if we add 0 to a value. Therefore, that is why it is called the identity. Everybody have that down? Not hearing from anybody. Cameras on for Mikai and Emma. So we just wrote down right? What happens when we add 0 to a number? Alright, and then we explained why 0 is the identity, because the value remains unchanged when we add that value, when we add that number to it. So the answer, the sum is the original number. So let's put that. The sum is the original number. Is the original number. Okay? Everybody understand?
Yes, sir.
So this is the identity for addition. Now we're going to go into the identity for multiplication. Can I erase the board? Can I erase the board, everybody?
Yes, sir.
Alright. Let me just take a picture of it if you haven't taken it off. and put it in the group. 1 second, I'm just put it in the group if you haven't taken it off. Alright, I'm going to take a picture of it. So, while you're writing it off, did everybody see the message I sent yesterday about a survey? Please ensure that you and your parents fill out one. Alright? Alright, so let's get into it now. Alright, let's say that I have 9 times 1. What is that equal to? 9. Alright? Let's find out the parts of this multiplication. What do we call the answer? Starts with P.
Product. So what did you say?
What do we call the answer when we multiply two numbers? We call it the product. Right.
Product.
Yes, product. The product. However, what do we call here? Quickly, one person tell me, what do you call these two numbers now?
Factors.
Something, I don't know.
Factors.
Are you somebody saying it?
Or is it factors?
Right. Alright? So when you have two numbers that can multiply to give you another number, they are called factors of that number. Alright? Let me just quickly give you a moment to turn it off. Here we go. Alright? Let me just go here. We're going to say factors now. That's the part of multiplication. But look at what we just did a while ago. When we looked at the identity of addition, we said it was 0. What do you think the identity of multiplication is going to be? Jazeel.
1.
1. Why is it going to be 1?
Because when I start with 0 and say multiply by the 1, it's still going to answer is still going to remain the same.
Right. When you multiply any number by 1, the product remains unchanged. So right up for me? When we multiply any number by 1, comma, the product remains unchanged. Therefore, 1 is the identity of multiplication. Any questions?
Sir, can you just leave that there for a while so that I can write it down?
Sure. What'd you say?
So I was just saying if you could leave it there so that we can write it down.
Oh, take a picture of it?
Yeah.
Alright, sure. So, what Payal said was correct, but actually, at 0, you said there were multiplicants and multiplicans, right?
Yes.
But you have multiplier and you have multiplicand. So, these are two actual parts of multiplication. So let me just add another pink line to explain that technically these two are called by other names as well. The first one being that we have the 9 being called the multiplicand, as Officer rightfully said, the multiplicand. Alright, and the 1 being the multiplier. Okay? Alright, so that was the identity for multiplication. Now, we're going to get into the identity now of the next one, which is going to be...
Sir, can I be excused?
Sure. So, there are only 2 identities in math, right? There's an identity for multiplication and an identity for addition. There is no identity for division nor subtraction. And I want one person to explain why is there no identity for subtraction in itself. Can I have off the board? Let me take a picture of it and just put it in the group before I forget. Why is there no identity for subtraction? Anybody?
Because whenever you try to subtract, so the answer will still.
Right. So no matter how big or small your number is, you will never just subtract anything and still get the same answer. Right? You can't subtract a number from that original number and get your original answer. Right? You can't say you subtract 0, but subtracting 0 isn't actually a large value. That's just not a number. 0. Alright, so those were the identities of addition and multiplication. The next thing we're going to learn is the inverse. Alright? So we're going to learn now for inverse. What comes to mind when you hear inverse? Let's say that I had 5 students in the class. Alright? So let's say we had 5 lovely students in the class. And suddenly, these students all had to use the bathroom all at the same time. Or they all went to the bathroom, so the cameras are off. Let's see how many students' cameras are off. 1, 2, 3, 4, 5. So we have 5 students that are not having their camera on. So let's wait until they're back. Kimani? Nicholas?
Sir, my camera doesn't work.
The camera doesn't work? Alright. Thank you. Okay, some of the students came back from the bathroom. Great. We're waiting on Nicholas. But in the meanwhile, so let's say now that we had 5 as our amount of students. What would be the inverse of 5? This question goes to at 0. What would be the inverse of 5?
Their inverse?
Yes. What would be the inverse of 5? Under addition. So, remember that question? What would be the inverse of 5 under addition? Alright? It's very simple. I want you to think about it like this. Addition has to deal with... Can you repeat that for me?
They're the inverse of 5?
Yeah, the inverse of 5. Just think about it in terms of what do you think would be the opposite of 5?
Minus 5?
Right. The opposite of 5, in this case, right here would be minus 5. Alright? And then now, once you work this out, 5 minus 5 gives you? What is 5 minus 5?
0.
0. So, for you to have the inverse under addition, you must have your answer being 0. So that means 0 is our identity for when you're finding an inverse under addition. So write that for me. Having an inverse, the sum must be 0 under addition. Alright?
So I can't see a part of it because it just.
Here we
Yeah,
go.
there.
Here we go.
Sir, can you take pictures of this and send it in the group chat afterwards?
Sure, sending it now. Alright, there you go. Check the group chat for me. Everybody ready again? So that was the inverse of addition. Now, there's an inverse under multiplication as well. But let's do one more example for inverse under addition. What if I had 3 students without their camera on? What would be the inverse of 3?
Minus 3.
Minus 3. Because the objective is always to get 0 as my identity. Alright, excellent. Let's move on now to the inverse of multiplication. Alright, so under multiplication now, inverse for multiplication. For multiplication, it's very simple. What multiplied by a number gives you 0 as your identity? Let's say I have 7. What can I multiply by 7 to get 0?
0.
0. Alright? So here's what we can say. If any number is multiplied by 0, then our identity will always be 0. Alright? So, with that idea, let's look at how a number could be inversed by multiplication. Look at this one now. Let's say I have 6 students. Let's say I have 6 students in the class. What would be the inverse What would be the inverse under multiplication? We did this back in fractions. Anybody remembers? When we're doing fractions, we found the inverse of those fractions. How would you make 6? Because remember, when you have 6, isn't it really 6 divided by 1?
6 divided by 1, sir.
Yes. 6 is the same thing as saying 6 divided by 1. So what is the inverse of 6 divided by 1?
1 divided by 6.
Right here, 1 over 6. Everybody agree?
Yes, sir.
Alright. Not just 1 over 6, but it has to be negative 1 over 6. So when I hear somebody say negative 1 over 6, yes, you're correct. Alright? The reason is that when I have now negative 1 over 6, right? Let's pair it together with our 6 we have. So let me just put this in white. The inverse of 6 on the multiplication is 1/6. Alright? Since 6 times 1/6, what would that give me? If I say 6 times a fraction of 1/6, what would that give me as my answer? Anybody?
Wait. You cross multiplication, can't you?
Remember, if you have two fractions, like 6 divided by 1 times 1/6, you can just multiply across.
1, you just be 1/1.
Yes, it would be 6 divided by 6, which is cancelled to be 1 by itself. So 6 into 6 goes 1, 6 into 6 goes 1. So we have our answer being 1. Alright? That is what happens now when you try to find the inverse. Alright? So that is the inverse rule under multiplication. For you to find the opposite of this number, right, you must be able to multiply it by that number and get only 1. And I'm going to write it right here. For you to find the inverse of any number under multiplication, you must be able to multiply that number and find a value of 1 as your identity. So can I have this part off? Let me take a picture of it first. Alright, here we go. Write this on it. For us to find the inverse, we must be able to multiply the two numbers and obtain a value of 1. Why is getting the value of 1 important? The first person to say it gets a prize. Why do we need to get a value of 1 when we find the inverse? Think about it. We just did a while ago a topic that talked about 1. What did we say about 1? In relation to multiplication. What is 1 in multiplication? Anybody? Nobody remembers? What do we say 1 is as it relates to multiplication? So we know that 0 is the identity of addition. Anytime you add a number to 0, it gives you back the number. But what happens when you multiply a number by 1? You get back the same number?
Yes, sir.
That means 1 is the identity of multiplication. So for you to have the inverse of multiplication, you must be able to multiply that number by the inverse and get 1, since that's the identity of multiplication. That is what makes a number multiplied. Any questions?
No, sir, I got it.
Alright, let's do one question to practice it before we move on. So let's say that I have